Kia ora and welcome to the September Jodcast from Space Place at Carter Observatory here in Wellington, New Zealand. After what felt like a long, cold, wet winter here in Wellington, September marks the start of spring in the Southern Hemisphere. As we head towards the equinox on the 23rd of the month, we see a rapid change in our daylight hours, with our days getting longer and our nights shorter. Equinox means equal night, because we have the same number of hours of daylight and the same number of hours of darkness at this time of year. By the end of September, the sun won't be setting until nearly 7:30. Jupiter is now our evening star, sitting in the west after dark. As we move around on our inside orbit, we're leaving Jupiter behind on the opposite side of the sun. At the beginning of September, it sits just below and to the right of Spica and sets shortly after 9 p.m. But it moves slowly towards the top right of Virgo's brightest star over the course of the month. And by the end, both will be setting by the time twilight ends. A thin 2-day-old crescent moon sits just below and to the right of Jupiter on the evening of the 22nd. In contrast to last September, when all 5 naked-eye planets performed a planetary dance, there is only one other planet visible unaided in our evening skies this month. Stunning Saturn sits high in the north as the sun sets. Scorpius Tematawamaui sits to its left, almost vertical, with its tail curling up close to the zenith. Whilst you won't be able to see anything from ground-based telescopes, it's an exciting time for our exploration of Saturn this month. After nearly 2 decades, including 13 years orbiting the ringed planet, the groundbreaking Cassini spacecraft will complete its grand finale when it plunges into the atmosphere of Saturn on the 16th of September, New Zealand time, sending vital new data to the end. The Cassini-Huygens mission has revolutionized our knowledge and understanding of the planet, its stunning rings and dynamic moons. The mission has revealed the complexity of Saturn's ring system, identified numerous new moons, and provided some of the most stunning images of the solar system that we've ever seen. It has found liquid oceans and a thick atmosphere on Titan, with conditions that may be similar to early Earth. An exploration of the icy moon Enceladus has revealed a hotspot at the southern pole, icy jets spewing out from the surface, and a vast ocean below the ice. Whilst there are only 2 evening planets you can see with your own eyes, Neptune is also in our evening skies, with Uranus joining it before 10 p.m. Both can be picked out with binoculars, and you may even notice a greenish colour to Uranus, but Neptune will be indistinguishable from a faint star. Now is the best time to look for the 8th planet, though, as it reaches opposition on the 5th of the month, when it will be directly opposite the Sun in the sky and at its highest in the north at midnight. At around this time, the planet will also be at its closest and brightest, shining at magnitude 7.8. and is sat less than a degree just below and to the right of the 3.8 magnitude star Lambda Aquarii, but you'll still probably need a detailed finder chart to spot it. Unfortunately, the full moon passes close to Neptune just after opposition, so it may be easier to find a week or 2 later. The bright stars Vega and Canopus mark north-south around dusk this month, guiding our eye to the bright band of the Milky Way passing high overhead. Along with the nearby bright stars of Deneb in Cygnus the Swan and Altair in Aquila the Eagle, Vega forms part of the Winter Triangle, as seen here in the Southern Hemisphere. Vega, in the constellation of Lyra, is the 5th brightest star in the sky, and at just 25 light-years away, one of the brightest in our local neighbourhood. It is also one of the best studied, and is used extensively by astronomers for photometric calibration. It was the first star outside our Sun to be photographed as early as 1850. Altair is also easy to spot, lying along the band of the Milky Way, midway up the northern sky after dark. Altair spins at almost 300 kilometers per second, so fast that it is not spherical but flattened at the poles. Deneb is harder to see, just skirting along the horizon from northern parts of the country. Between Vega and Altair is Albireo, or Beta Cygni, the beak star marking the head of the swan. Although it appears as a single star to the naked eye, Albireo is in fact a double star and a lovely sight in a small telescope, or even a good steady pair of binoculars, because of the easily seen contrast in colour between blue and gold components. The 2 stars are 35 arcseconds apart, meaning they are separated by 60 times the diameter of our solar system, and may take 100,000 years to orbit each other. Alberio is best viewed using low magnification, as the colours stand out more clearly when the stars appear close together. Try defocusing your telescope a little to spread out the star's light, so the colours are easier to see. A similar distance to the other side of Altair is Alpha Capricorni, the third brightest star in the zodiac constellation of Capricorn, the goat, despite having the Alpha designation. Alpha Capricorni is commonly known as Algiedi, meaning the kid, and is another double star, but this time the effect is purely coincidence. Although these stars appear close together, this is just a line-of-sight effect, with the two components positioned at 109 and 690 light-years away. Alpha 2 or Secundagiedi is the closer and brighter of the two at magnitude 3.58. It is itself a triple star system, with the primary component an evolved G-type star with twice the mass, 8 times the radius, and 40 times the luminosity of the Sun. Alpha 1 or Prima Giedi is a supergiant over 5 times more distant, but at 5 times the mass and over 1,000 times the luminosity of the Sun, it is only slightly fainter in our skies at magnitude 4.3. Alpha Giedi is also a multiple star in its own right, comprising another evolved G-class star with at least 3 faint companions nearby. Prima and Secunda are located 6.6 arc-minutes apart, around 1/5 the diameter of the full moon, and can be separated fairly easily even with the naked eye. To the southeast of Capricornus is the faint constellation of Pisces Austrinus, the southern fish, with its only bright star Fomalhaut marking the mouth of the fish. Fomalhaut is the 18th brightest star in the night sky, and the only lonely bright star in its vicinity. Along with TW Pisces Austrini and LP 87610, Fomalhaut is part of a triple star system, one of the widest triple stars known. The primary Fomalhaut A and secondary TW Pisces Austrini or Fomalhaut B are separated by a couple of degrees on the sky, and in reality are almost a light-year apart, but they are at a similar distance from Earth and co-moving through space. The third component, Fomalhaut C or LP 87610, is a faint red dwarf which is separated even further, some 2.5 light-years from Fomalhaut A and 3.2 light-years from Fomalhaut B. It wasn't until 2013 that Fomalhaut C was found to be part of the system, as it sits over 5 degrees away on the sky. Fomalhaut has been the subject of some controversy over the past few years. In 2008, astronomers identified a massive planet orbiting the star. But what was really exciting about this detection was that this planet, called Fomalhaut B, was the first to be discovered by direct imaging, appearing as a small cluster of pixels in images from the Hubble Space Telescope. Follow-up observations, however, failed to confirm the planet and left many doubting its existence. It took until 2012 before Fomalhaut B was independently detected and confirmed. Its controversial past has earned it the nickname the Zombie Planet, a planet resurrected from the dead. Wishing you clear skies from the team here at Space Place at Carter Observatory.